Welcome students on online class for the subject physics. Today we have learned chapter number 5, oscillation. In this chapter we have learned examples to determine resultant amplitude, resultant initial angle or epoch of two S.H.M, two simple harmonic motion. So first of all, we have seen when two S.H.M having different displacement, x1 equal to a1 sine of omega t plus alpha 1 and x2 is equal to a2 sine of omega t plus alpha 2. The two S.H.M having different displacement, different amplitudes and different initial angle, so that their resultant amplitude is a equal to square root of a1 square plus a2 square plus 2 times a1 a2 cosine angle alpha 1 minus alpha 2, where alpha 1 minus alpha 2 is called as phase difference. Again, here we can find out resultant initial angle or resultant epoch. So delta is equal to tan of inverse in bracket a1 sine of alpha 1 plus a2 sine of alpha 2 upon a1 cos of alpha 1 plus a2 sine of alpha 2. Again, we can use the formula for omega equal to 2 pi upon capital T, or omega is equal to 2 pi into frequency. This formula. Again, if we can see the angle, suppose angle of sine 30 means sine of pi upon 6, it has the value 1 upon 2. Similarly, sine 60 degree has sine of pi upon 3 having value square root of 3 upon 2. Again, if we see cos of 30 degree means cos of pi upon 6, then its value will be square root of 3 upon 2, and cos of 60 is cos of pi upon 3 means its value will be 1 upon 2. Using these values we can solve the different examples on two S.H.M. So the first example will be displacement of particle performing simple harmonic motion along x-axis is x equal to 8 sine of 4 pi t plus 6 cos of 4 pi t in CGS systems. Show that the motion of particle performs simple harmonic. Again, we want to find resultant amplitude, time period, frequency, initial angle. So we have seen this example will be, we can write it given example, x is equal to 8 sine of 4 pi small t plus 6 cos of 4 pi t small t. Here, if we can differentiate the equation with respect to time, dx upon dt, it will be derivative with respect to time 8 sine of 4 pi t plus 6 cos of 4 pi t. So here its value will be 8 cos of 4 pi t multiplied by 4 pi plus 6 minus sine of 4 pi t multiplied by 4 pi. Again, we can written as 32 pi cos of 4 pi t minus 24 pi sine of 4 pi t. Again, if we differentiate the equation with respect to time, so that derivative with respect to time into dx upon dt, it will be derivative with respect to time 32 pi cos of 4 pi t minus 24 pi sine of 4 pi t. See here, 32 pi minus sine of 4 pi t into 4 minus 24 pi cos of pi t, 4 pi t into 4 pi. So here we can write as 32 into 4 pi minus sine of 4 pi t minus 24 into 4 pi cos of 4 pi t. So here in this case 4 multiplied by 4, 62 is common, minus 16 is common, so minus 16 pi. In bracket it is here 2 and 4 will be 8 sine of 4 pi t plus here 6 pi cos of 4 pi t. So we know that 8 sine of 4 pi t plus 6 cos of 4 pi t equal to x. It will be, so here 4 pi get pi square, 4 pi get pi square, so minus 16 pi square, so minus 16 pi square x, it will be d2x upon dt square. We know that it can written as minus omega square x, therefore d2x upon dt square plus 16 pi square x is equal to 0. Comparing with, we can write as omega square is equal to 16 pi square. Take square root of, we can write omega is equal to 4 pi. So first we can find out omega, which is 4 pi radian per second. Here we can find out time period, we can find out frequency. For time period, t equal to 2 pi upon omega, 2 pi upon 4 pi, pi get cancel, then 2 to the 4, t equal to 0.5 second. Here time period will be 0.5 second or 1 upon 2 second. But we know frequency omega equal to 2 pi n. So frequency is equal to omega upon 2 pi, means 4 pi upon 2 pi, pi get cancelled 2. So frequency is equal to 2 hertz. We can solve the two equations. But here, if we write the two S.H.Ms like x1 is equal to a1 sine of omega t plus alpha 1 and x2 equal to a2 sine of omega t plus alpha 2. Compare the equations. We can take an as a1 has value 8, a2 has value 6. They are in CGS system, so 8 centimeter, 6 centimeter. So that alpha 1 0, alpha 2 0, and here omega it will be 4 pi. By comparing, we can find out resultant amplitude. So resultant amplitude A is equal to square root of a1 square plus a2 square plus 2 times a1 a2 cos of alpha 1 minus alpha 2. Here alpha 1 is 0, alpha 2 is 0. The value, this value will be 0. So a equal to square root of a1 square plus a2 square. By substituting the value, square root of 8 square plus 6 square is equal to square root of 64 plus 36 is equal to square root of 100, which is equal to square root of 10 to the power 2. And therefore the resultant amplitude is equal to 10 centimeter. Again, if we solve, if we can solve resultant initial angle delta is equal to tan inverse a1 sin alpha 1 plus a2 sin alpha 2 divided by a1 cos alpha 1 plus a2 cos alpha 2. So here we can take an as alpha 1 is 0, alpha 2 is 0, cos alpha 1 is 0, alpha 1 and alpha 2 are 0. So we know that sin 0 will be 0. So here delta is equal to tan inverse a1 sin alpha 1 upon a1 cos alpha a2 cos alpha 2 or cos alpha. So what happened here? Therefore delta is equal to tan of inverse a1 and a2. a1 having value 8, a2 having value 6. If we divide both term, it will be tan of inverse 1.25 2 is remaining, 20, 3, 3, 3 is there. So delta is equal to tan inverse. See here, by using logarithm, natural tangent will be seen 1.33. So here 1.3270, 3319, and here 16. So it will be 53 degree 8 minute. 8 minute. That is the answer for the given question. Again, if we solve another example, that example will be 2 S.H.M is given as x1 is equal to 5 sine of 6 pi t plus pi by 3 and x2 equal to 12 sine of 6 pi t plus pi by 6 are superposed on same particle. Find resultant amplitude, the resultant initial angle of 2 S.H.M. x1 and x2 are expressed in centimeter. So here compare the two equations with x1 equal to a1 sine omega t plus alpha 1 and x2 equal to a2 sine omega t plus alpha 2. If we can compare, so here we can write as data. A1 5 centimeter, A2 12 centimeter, alpha 1 pi by 3, alpha 2 pi by 6, omega 6 pi, and we can find out resultant amplitude A and we can find out resultant initial angle delta. So first, using formula for resultant amplitude, A is equal to square root of a1 square plus a2 square plus 2 times a1 a2 cosine alpha 1 minus alpha 2. If we substitute the values, it will be square root of a1, that is 25, 5 square means 25, a2 it will be 144 plus 2 times 5 into 12 cos of pi upon 3 minus pi upon 6. We can use 60 minus 30. It will be square root of 25 plus 144 plus 120 cos of 60 minus 30. It will be cos of 30 degree. And we know that cos of 30 will be square root of 3 upon 2. So here square root of 25 plus 144, it will be 169 plus 120 multiplied by square root of 3 upon 2. So here 60. We can find or we can know value of square root of 3 will be 1.732. So here square root of 169 plus 60 multiplied by 1.732. It will be 169 plus 0, 6 to the 12, 1 is remaining, 6 3 the 18, 19 is there, 1 is remaining, 6 7 the 42 and 1 43, 4 is remaining, and 6 1 the 10. So we can write 169 plus 10, it will be 179 1, 2, 3. So here 103.90. So 103. So it is 12, 7, 2, 227.92. If decimal point is shifted, it will be square root of 2.7292 into 10 to the power 2. If we see the square root, its square root will be 1.652 into 10. So here a resultant amplitude it will be 16.42. So resultant amplitude will be 16.52 centimeter. We want to find resultant initial angle. So delta is equal to tan of inverse in bracket a1 sin alpha 1 plus a2 sin alpha 2 divided by a1 cos alpha 1 plus a2 cos alpha 2. If we substitute the values, so it will be tan inverse in bracket a1 is 5 into sin of alpha 1 pi by 3 means sin 60. So here sin 60 it will be 1 by 2 plus a2 will be 12 multiplied by sin 30, and sin 30 it will be under root 3 upon 2 divided by a1 5 into cosine alpha 1 means 60, cosine 60 it will be 1 upon 2 plus cosine 60 will be square root of 3 upon 2 plus a2 is 12 multiplied by cos of 30 it will be 1 upon square root of, here alpha 2 will be 30 and cos of 30 it will be square root of 3 upon 2. So here we can use and 1 upon 1 by 2 and 5 into 1 upon 2 into 12 into square root of 3 upon 2. What happened? So it is tan inverse 5 square root of 3 plus 6 upon 5 plus 12 square root of 3 into 1 upon 2 divided by 1 upon 2. Get cancel. 5 to the 10, 1 is remaining, 5 to the 6, 15 and 1, 16 is there, 1 is remaining, 5 7 the 35, 36 is there, 3 is remaining, 5 1 the 1 becomes 8. 8.660 plus 12 upon 5 plus 12 to the 24, 12 3 the 36, 3 is remaining, 12 7 the 84 and 3 87, 8 is remaining, 12 1 the 12 plus 8 20. So it is tan of inverse 20.660 divided by 2 1 the 2, 2 10 the 20.382, that is 15.382. By solving, so delta is equal to, it becomes tan inverse 1.343 and delta is equal to 53 degree 21 minute. Two S.H.M have mean difference, mean position period on same line of vibration and same amplitude 10 cm. If phase difference is 60 degree, find resultant displacement when two S.H.M are cross with each other from their mean position. See the example here. By using data, amplitude will be 10 cm and alpha 1 minus alpha 2 is equal to delta, which will be 60 degree, that is pi upon 3. So here we can use resultant displacement x is equal to question mark. We know resultant displacement x is equal to resultant amplitude sine of omega t plus delta. For same line, omega is equal to 2 pi. If t equal to, we can find out in, or we have 1 second, then we can find x is equal to 10 sine of 2 pi into 1 plus delta, it will be pi upon 3. So what happened? 10 sine of 6 pi plus pi upon 3. It is 10 sine of 7 pi upon 3. We use 10 sine of pi by 3 and we know that value of pi by 3, sine of pi by 3, it will be square root of 3 into square root of 3 upon 2 will be 5 into square root of 3 centimeter. But if we substitute the value of square root of 3, which is 1.732, so here we can find resultant displacement will be 5 into 1.732, 5 to the 10, 1 is remaining, 5 3 the 15 and 1 16, 1 is remaining, 5 7 the 35 and 1 36, 3 is remaining, and 5 1 the 5 and 3 8. So it will be 8.660 centimeter. That is the answer for given example. Again, if we solve another example, that is a body is subjected simultaneously to two S.H.M, has amplitude 3 cm and 4 cm, has time period 2 seconds and phase difference pi by 3. Find resultant amplitude, resultant phase. Also find maximum velocity and maximum acceleration of a body. See here, if we write data, it will be two amplitudes. One, A will be 3 cm, A2 will be 4 cm. Time period, t is equal to 2 seconds. So omega is equal to 2 pi and pi radian per second. Again, here we can find out resultant amplitude A, we can find out delta, we can find out maximum velocity, acceleration maximum. Means 4 questions can be solved. So using this, first of all, resultant amplitude A is equal to square root of a1 square plus a2 square plus 2 times a1 a2 cosine the alpha 1 minus alpha 2. See here, the phase difference, that will be pi by 3. So we can write as delta is pi upon 3. So here alpha 1 minus alpha 2 equal to pi upon 3. So resultant amplitude A is equal to 3 square the 9 plus 4 square the 16 plus 2, 3 multiplied by 4 cos of pi by 3. We know the value of cos of pi by 3. So cos of pi by 3 will be 1 upon 2. So it is square root of 25 plus 24 multiplied by 1 upon 2. It is 12. So resultant amplitude A is equal to square root of 13, which is 37, which square root will be 6.083 centimeter. That is the resultant amplitude. The first answer. Second answer will be delta. We know that tan inverse a1 sine of alpha 1 plus a2 sine of alpha 2 divided by a1 cos alpha 1 plus a2 cos alpha 2. So here sin 0 will be 0, 0 upon any terms will be 0. So delta will be 0 because tan 0 has value 0. Again, we know that omega, it will be pi radian per second. So we know that maximum velocity, it will be a omega. So value of a will be 6.083 multiplied by pi. So here 6.083 pi meter per second or centimeter per second, that is the velocity. But if we can put the value of pi, 6.083 multiplied by 3.142 centimeter per second. By solving 0.0 plus 60 in 8 and 3 is in mean difference, it will be 7841, and here log will be 4972. So 3, 11, 18, 12, 1 point. If we can take its anti-log, so it will be 1.911 into 10 raised to 1. So 19.11 centimeter per second is the answer for maximum velocity. We can find out maximum acceleration. It will be a omega square, means a omega into omega will be 19.11 multiplied by 6.083. If again we can solve by using logarithm, so logarithm will be 1.0 point addition. So here log of 19 in 1 in mean difference, it will be 2812, and here 6.083, so log will be 7841, 3, 5, 16, 10, and here 2. By taking antilog of 0.06 in 5, 3 is in mean difference. It is 1.162 multiplied by 10 to the power 1. So it will be 10 to the power 2. It will be 116.2 centimeter per second. is the answer for maximum acceleration. Again, we have solved another example. In this another example, here displacement of particle in motion x equal to a sin omega t plus b cos omega t in meter, where a, b and omega are in constant, show that the motion is simple harmonic. If a is equal to 3, b equal to 4 and omega equal to 2 radian per second, find time period, maximum velocity, maximum acceleration. So first we want to solve by showing the motion is simple harmonic. So here given equation will be x is equal to a sin of omega t plus b cos of omega t. Take derivative, it will be dx upon dt will be a cos omega t into omega plus b in bracket minus sin omega t into omega. It will be a omega cos omega t minus b omega sin omega t. Again, if we can again derivative with respect to time, so it will be d2x upon dt square, or derivative of dx upon dt will be a omega minus sin omega t into omega minus b omega sin omega t into omega. It will be minus a omega square sin omega t minus b omega square sin omega t. Again, here omega square is taken as common, minus omega square if we can take common, it will be a sin omega t plus b sin, here its derivative it will be cos omega t, and therefore b cos omega t. So here a sin omega t plus b cos omega t will be x, and therefore d2x upon dt square will be minus omega square x, and therefore d2x upon dt square plus omega square x is equal to 0, which is differential equation. And so motion is simple harmonic. If the two amplitudes are there, a equal to 3 and b equal to 4, they are in meter, 3 meter, 4 meter, and we can find out resultant amplitude. Therefore resultant amplitude alpha 1 minus alpha 2 is 90 degree or is not given. So resultant amplitude a equal to square root of a square plus b square. It will be square root of 3 square means 9 plus 16, square root of 25. So resultant amplitude will be 5 meter per second. Again, we can find out time period. So time period will be t equal to 2 pi upon omega. So 2 pi upon 2, it will be pi second, will be 3.142 second. That is the time period. Again, maximum velocity, v maximum is equal to a omega. So 5 into 2 meter per second will be 10 meter per second. And again we can find out maximum acceleration. So maximum acceleration equal to a omega square will be a omega into omega, that is 10 into 2, it will be 20 meter per second square. This is the answer for given example. So there is an assignment for solving the student to prepare more and more practice.